Now, this is a new term which we will be dealing with, especially network diagrams. Okay. So till now we have been discussing about how to create network diagrams and how to find out the scheduling of or find the critical path and then the critical activities in the network diagram. Then we also saw how to find the different types of floats. And then we, in the PERT, especially for PERT technique, we saw how we can, find out the probability of completing a particular project in the given duration. So we also saw about the normal distribution pattern, the probability we did that in the last session. Okay. Now, when we talk about network crushing, okay, it is a very important task. Here, till now, we have been considering only the duration, the time. We never focused on the resources and the cost which is involved in completing a project. Okay, so network crushing actually deals with, or it actually considers the resources requirement and especially the cost which is involved in completing the project. Now, when we say network crushing, we will be talking about reducing the duration of your critical activities such that we make use of the optimum use of resources and the time so that my overall cost of the project reduces. Okay, that is the whole purpose of network crushing. Now, to just go through one small definition, we can say network crushing is the method for shortening the project duration by reducing the time of one or more critical activities. Please remember, it has to be only for the critical activities to less than the normal time. Okay. Now, crushing is achieved by denoting more resources. Now, if I am denoting more resources, of course, the cost of the resources will be involved. But remember, if I reduce the time, the cost might increase. Okay, and if there is some like if you remember in PERT, we had some floating times. So the floating times were the times by which we cannot delay a particular event. If it is a critical activity, the floating times of free float, independent float, these were zeros, right? That means we cannot delay those activities. Whereas the non-critical activities could be delayed because the floating points, the floating time which was there was involved. Now, in this case, we are going to crush the reduce the time of a critical activity, such that my cost should not increase, the overall cost should not increase, and I should be able to complete my project in the optimum time and the optimum cost. That is the whole purpose. And of course, what is going to happen? There are two components of a project cost. The first component is your indirect cost, and the other one is your direct cost. So let us see those components. So when I talk about the components, the indirect cost, now this is the cost which is in the form of, say, overheads, then office and administrative expenditure, penalty for delay and bonus for early completion. This constitutes the indirect cost, which might vary with time. So any reduction in the project duration results in reduced indirect cost. But remember, if I'm reducing the duration, I might have to apply more labor or might be more resources to complete the project. So we are going to consider that will be involved in your direct cost. So when we talk about the material consumed, the cost of machinery used, and the payments made to the labor and subcontractor, if there are any, for executing your project activities. So while estimating the duration of these activities, it is assumed that the normal amount of labor and machinery would be utilized, resulting in the minimum direct cost. Now, please remember, for completing the work in a shorter time, as I told you, additional cost would be incurred, especially if I am employing more machinery. Might be I have to purchase new machinery or I have to take it on rent. So there is a cost involved there. Or might be I'll employ more labor. Okay, so, again the cost will be involved. Or the laborers might do some overtime. So again, my overtime allowance will increase the direct cost. Now also remember the direct cost will also increase if I'm not able to complete my overall project in the given duration. So if there is less productivity or insufficient functioning of my labors, then the work might get dragged and it might not get completed in the given duration. That is my depending on the critical path and the critical duration. So even in that case, my direct cost can increase. Now, looking at the different types of cost, yes, anyone wanted to ask some question? Okay, going ahead. If you look at the different types of cost there, especially your indirect cost and your direct cost together, there is always a relationship between the time duration and the cost. Okay, if you search on the net, you'll find a graph. If I plot a graph of time versus your cost, you'll get a different type of a curve. Especially with time, the cost might go down initially, and as you go forward, it might increase. So we need to find the exact location or the position or the time at which my cost is less and my duration is also less. Okay, so there are two things, or there are some procedures which we are going to follow when we actually perform your network crushing. Now I'm going a bit fast because there's a problem which I want to complete, which will be a lengthy one. So just go through all the steps. Please note down each and every step which is involved while performing this network crushing procedure. Now, as you know, the whole process is of shortening the project duration, and it is known as crushing. Now, we can achieve that by reducing the time for the critical activities only, and not the other activities. And one more thing we need to be careful is when we are crushing the activity duration, my critical path should not change. It should, that or the path which is already there, the critical path which is already there, should not change to some other path. That is what we need to be careful about. Okay, there are some terms which we are going to make use of while discussing the procedure. First is your normal time, which is the duration which we actually get for completing a task. Then we have the normal cost which is involved for completing that activity. Now you will be provided two more information. That will be your crush time and your crush cost for all the activities will be given to you. Now using all these four values, we are going to go ahead and find the optimum cost and the optimum time for completing a particular project. The first step, as we already have learned how to draw a network diagram, we will be drawing the network diagram first. So the first step would be to draw a network diagram and find the critical path. Now you already know the method of finding the critical path. There are two ways. Either you can make use of the values of E's and the L's and check if they are same. Then those activities or those nodes fall on the critical path. Or if the network diagram is not very complicated or complex, you can mention all the paths which are available in the network diagram and find the duration. Your critical path is the path which takes the maximum, you can say, duration to complete. And all the activities on the critical path are the activities which cannot be delayed at all. Okay. Once we find the critical path, we are going to find the normal project completion time by just adding the normal time of all the critical path. That is nothing but your critical duration or duration for the path, which we have done before as well. But along with this, we are also going to find out the normal project direct cost. So by adding the normal cost of all the activities, we will get the project direct cost. And finally, using the direct cost and the indirect cost, we are going to find out the total project cost. That will be the first step. Okay. The second step is to compute the cost slope for all the critical activities. Now, there's a formula involved while calculating the uh, cost slope for the critical activities, which is given by crash cost minus normal cost divided by normal time minus crash time. Okay, so using this formula, we are going to find out the cost slope. Now, this indicates the extra, you can say the direct cost required to expedite the activity by 1 unit of time. So, of course, this is going to involve some cost if I am going to reduce my, you can say, time duration to complete that particular activity. Okay. Once we find this, the next step is to do the activity crushing. Now, activity crushing means we have to identify the critical activity with the lowest cost slope and crush it. When I say crush it, we have to reduce its activity time duration. Now, one more thing, as I told you, your crush time will be given to you, but it need not be that you have to use the full crush time to reduce the duration. Okay, so we need to find, after crushing, we need to check whether my critical path is changing or not. And as I told you, it should not change. Okay, so we have to crush that particular activity to the extent such that it does not change the critical path. That is very important. Okay, if by chance you're crushing that particular activity by the total crush time given to you, then it's fine, no problem. Right? So crushing, activity crushing is very important step, and we have to be very careful while doing this. Now, after doing this, we are also going to find out the new project completion time, and we are going to compute the new direct cost and the new total cost. So again, I have to draw the network diagram. Okay, find out the values of E's and L's, find out the direct cost, the new project time, and also the total cost for the new crushed, you can say, network diagram. Okay. Now, activity 3, or you can say 2 and 3, will repeat depending on the different types of critical paths. If suppose by chance after crushing, and you try to find out the critical path, and you find out that there's multiple critical paths now, then you have to involve those critical paths as well while we are doing the calculation for your cost slope. Okay, so this is a very repetitive step and it is lengthy. Step number 2 and 3 will go on till we actually find the optimum cost. Okay, so the step 4 would be to find the further scope for crushing, whether I can crush it further. And as I told you, we need to find the direct cost and the total new cost as well. The fourth step, to find the further scope for crushing. Now, what are the different, you can say, after crushing, what is a critical activity? It can happen if the previous critical path is still the only critical path, then we can ignore the step number 2, where we are calculating the cost slope, and we can directly go to step number 3 and check which activity can be crushed. Okay, again, we can find out the lowest cost slope and crush that particular activity. If suppose we get other paths, which is also your critical path now, we can get either a parallel critical path, then we have to crush all these critical paths simultaneously. Okay, now while doing it simultaneously, either it can be a parallel or it can be continuous. Okay, step number 2 and 3 has to be repeated in this case. Now, the third one will be if suppose we see that all the critical activities are crushed to their lowest possible time, then we should stop the overall activities or the procedure and then try to find out the optimum project time and the project cost. That will be the 3 steps which will be involved in step number 4. which is your last step. Now, to take an example, I would like to take an example also. So let us take an example. Before that, let me check whether I have some. Okay, optimum project time and cost that I'm going to skip right now and directly come to an example. Please note down this example. And as I told you, it's very important as this is a new topic altogether. Please pay attention carefully and practice it simultaneously. Wherever you have any doubt or problem, please ask me immediately. Okay. Now there's a table given to us where we have the tasks and the immediate predecessor along with the normal time given to you. Now using the tasks, the predecessor and the time in which we will be drawing the network diagram first. So once we draw the network diagram, please use the forward pass and the backward pass to get the values of the E's and the L's. Okay. We also have the normal cost given to us, which is in thousands. So the first value for A, the task A, we have the cost is 20,000. Then we have got the crush time. That means I can crush the task A to 7 weeks, and the cost which is involved is 30,000. Okay. Now I have to crush only the activities which fall on the critical path and not all the activities. Now we also have been given the indirect cost. So indirect cost, that is your fixed cost, is given as rupees 400 per day. And we have to find the optimum duration and the associated minimum project cost. Now I won't waste any time. Directly I'll show you the network diagram. So let us see the solution for this. As I said, the first step would be to find the critical path. Now using the techniques which we have learned till now, use the forward pass and the backward pass and you get a network diagram like this. Please go through this network diagram. And if you look at, there's one activity which has been added, which is a dummy activity, 3-4 with duration 0 in it. And the critical path is coming on 1, 2, 3, 4, and 6. And if we add the duration, so 8 plus 6, that is 14, and 14 plus 12 gives you 26. That is your critical path and the critical duration, the total duration, or you can also call it as your normal duration now. Okay. What are your critical activities? Your critical activities is your D, E, and G. Okay, this is your critical activities which can be crushed now. Okay. Advaith has a question, sir, how to know where to add a dummy. Okay, Advaith, if you remember, as I told you, if let us say there's from activity 2 or from this node 2 to node 4, I have one activity C, right? So there's C going here. Can I put one more line from node 2 to node 4? It's not possible. As I told you, if you have two nodes, you cannot have two activities. You can say coming out of one node and merging in the same node, which is not possible and which is not allowed at all. And to overcome that problem, we introduce another node here, and that's the reason we have put this node here and we have created this dummy activity. Okay, so dummy activity will be introduced when we have more than one activity which is coming out of the same node and merging in the same node. Please remember this. And secondly, if you look at G, okay, the preceding activity for G is A, C, and D. That means D should merge in the same node here, so that we have this activity G coming out of it. And that's the reason we have introduced the dummy activity. Clear? I hope I have made it clear. But still, if there are doubts, when you are practicing I'll give you some questions to practice. When you're practicing, you'll understand that where are the nodes where we actually require the dummy activity or dummy task, you can call it. Okay, any other question here? Now I have represented my critical path with the double line followed with the arrow here. Okay, and immediately we are supposed to calculate the direct cost, the indirect cost, and the total cost for this. So if you do the calculation, let us find the calculation, the values. So my critical path, as I told you, is 1, 2, 3, 4, and 6. While my activities are, or the events are, D, D, and G. Okay, we do not consider a dummy in the calculation because the duration is 0. So the total duration is coming to 26 weeks. And if I find out the direct cost, 20 plus 15 plus 8 plus 11 plus 9 plus 5 plus 3. Now, from where are we getting these values? These are the values for your normal cost. Okay, the normal cost from the table. This one, this cost here total. Okay, so 20 plus 15 plus 8 plus 11 plus 9, then plus 5 and plus 3. Okay, now because the cost is given in thousands, we have to multiply this by 1000, and that's the reason I have multiplied this by 1000. So my direct cost is coming as 71,000 here. Now your indirect cost depends on the critical path. Okay, the duration is 26 days. So 26, not days, weeks. So we multiply that by 7. And your indirect cost per day is given as 400. So we multiply this by 400. And the answer which we are getting is 72,800. We add the direct cost and the indirect cost to get the total cost, which is coming as 1,43,800. Okay, so this is my first step. Once I complete this, okay, please remember the minimum project crush duration should be equal to your addition of your crush time of all the activities. So if I add all the activities, the crush time for all the activities, check the duration, what it is, you'll get to know the crush time for all the critical activities. What is the next step? The second step is to find the cost slope for the critical activities. So let us go to the next step. Now, the addition of the crush time for all the critical activities coming to 18 days. So now let us find out the cost slope. Now for B, D, dummy, we are going to put a dash there. It's not required at all. And G, these are the critical activities for which I need to find out my cost slope. The formula, as you already know, 20,000, I'm using thousands here. Normal cost minus the crush cost, which is 15,000, divided by the normal time minus, sorry, the crush time minus the normal time minus the crush time. Okay, and 20,000 and 15,000 for activity B. Let us see activity B. 20,000, that is your crush cost, and 15,000 is your normal cost. Okay, so crush cost minus normal cost divided by normal time minus your crush time. Okay, which is 6. This gives you 2,500. Similarly, do it for D and G. So we get 2,000, and finally for G, we are getting 250. Okay. Now find out, the next step would be to find the lowest cost slope. Now the lowest cost slope is for activity G. Okay. So we can crush this activity by some days. Let us go back to the table. So activity G, the crush time is 8 weeks and the normal is 12. That means I can crush this activity by maximum 4 weeks. Okay. Now let us go back to the diagram here. Okay. Now if I crush this by 4 weeks, we can see that the activities do not change. So actually, after crushing it by 4 weeks, we need to draw the diagram. I am directly showing you the answer here. The values of your E's and the L's should not change, and the path, as I told you, the critical path should remain the same. Okay, and after crushing it by 4 weeks, we still get the same critical path, and that's the reason we will crush the activity G by full 4 weeks. It can happen that the critical path changes and it does not remain the same. In that case, we should reduce the crush time. Okay, so instead of crushing it by 4 weeks, we can check it with 3 weeks or 2 weeks or 1 week. It's up to you. Okay, we need to check. Why we need to check? So that the critical path should not change. As I am repeating this again and again, the critical path should not change when I'm crushing a particular activity. Please remember. Okay, so the maximum weeks which I can crush activity G is 4, and by doing that, I'm not getting the new critical path. Neither my critical path is changing, and that's the reason I'm going to crush this whole activity by 4 weeks, and I'll get a new network diagram. Now to draw the network diagram again, okay, and calculation of the total cost has to be done again. So here we go, the calculation. If I reduce the activity G by 4 weeks, my overall duration is changing to 22 weeks. And my new total project cost is coming as, this is my previous cost which I had calculated. Okay, 71,000. If you remember, this was 71,000 here, where it is here itself. This was 71,000, which was my direct cost. Indirect cost was 72,800. Now, what is going to happen is my direct cost is going to increase and my indirect cost is going to reduce. Why it is going to reduce? Because the duration has reduced. Clear? So the new total, this is my new total. You can see this one. It has been increased. So 4 weeks, 4 multiplied by 250. Okay, plus into bracket 22 multiplied by 7 multiplied by 400. Now, from where we get this 250? 250 is coming from the cost slope. This one, this value 250. Okay, cost slope per week, and that's why we multiply this 4 by 250 and add it up. This gives you 72,000 here, and as you can see, this value has changed, and my overall cost has also reduced. So it is now 1,33,600. Now, after doing this, we have crushed only activity G. Neither I have got any new critical path. So we need to first of all draw this path again, the new network diagram again. Okay, and you can see that I have put a cross here for this critical activity G, because I have crushed to the maximum which I can crush the activity G for, that is 4 weeks. Okay, so I cannot crush this activity further, and that's the reason I put a cross here. Okay, and my new duration for G is now 8 weeks, and that's the reason you can see this value has changed. Instead of 26, it has become now 22. Okay, now once we do this, there are still activity B and D which can be crushed, which is the least cost. The least cost slope is for activity D, so I can crush activity D further. Okay, so if I do that, what is the duration by which I can crush it? Let us go ahead and check it out. So the fourth step is the slope for crushing again. The critical path is 1, 2, 3, 4, and 6, and it is the only critical path. And now we are getting the next lowest cost slope is for D. Okay, and as we can see, D is having the normal duration as 6 and the crush time as 4. That means I can crush it by 2 weeks. But again, as I told you, you need to check whether if I add crush it by 2 weeks, whether my critical path changes. Okay, it should not change. And in this case, if I crush it by 2 weeks, my critical path it changes. Okay, so I cannot crush it by full 2 weeks, and that's the reason I have to crush it by 1 week. Okay, for knowing whether my critical path is going to change, you need to do the calculation for your E's and the L's. Okay. So in this case, because I cannot crush the activity D by 2 weeks and crushing it only by 1 week, I get the new cost again. I have to find out the new values of L's and the E's. That means you need to draw the network diagram again, find the new critical path, find the total cost again. And in this case, now look at the network diagram. I have got some new critical path as well now. Okay, so there are more than one critical path. Now we get this 1, 2, okay, 3, 4, and 6 still remains the critical path, and it should remain the critical path. Whereas there are 2 more critical paths which have been added now, which is B, C, and G, and D, E, and F. These are the critical activities which have been added. Now, as I told you in step number 4, if the multiple critical paths are created, I need to do the crushing simultaneously. Okay, so I'll be involving all the 3 paths while doing the crushing in the next step. Okay, so the next step would be to crush it further. But before crushing, we need to find out the new cost slope for the other critical activities which have been added now. Okay, so again, do the calculation. These are my 3 critical paths now, you can see, with the duration as 21 weeks. Please remember one more thing: when we are doing the crushing of your network diagram, you will land up with all the activities will become critical path. Okay. Okay. And might be the optimum cost does not have all critical activities, or it can have all the critical activities. So all the activities in your network diagram might turn out to be critical activities. Clear? So now please remember, once we get multiple critical paths, we can do the crushing simultaneously, okay, parallelly. So in the first activity, you can see 1, 2, 1, 2, 1, 2 is always there. So B is my common activity here. Okay. Whereas we have 2, 4, that is 2, 4, that is C. Here we have 2, 3, that is D. And we have 2, 5, 2, 5, E. That means C, D, and E will be crushed simultaneously. Okay. Then we have 4 and 6. 4 and 6 cannot be crushed further because you can see I have already put a cross there. I cannot crush it. The optimum crushing is already been done by 4 weeks. Dummy cannot be crushed. Okay, so next step would be simultaneously I need to, because F is left, C, D, and F can be crushed simultaneously. Okay, so there will be now, we have to find out the cost slope for critical activity B, which is common, then the parallel activity C, D, and E, and then finally C, D, and F. Okay, so let us see that table now for the cost slope. Here's my table where I'm calculating the cost slope for B, which is common in all the 3 critical paths. Then the parallel activities, which is CDE and CDF. Okay, please add it up. Now, this is more important. The last, you can say the last column, the maximum crushing duration for B is given as 2. For C is 1, for D is 1, and for E is 3. Now, you'll see that we have already crushed D. Actually, in the initial phase, the crushing time for D was 2 weeks. Because we have already crushed by 1 week is left. Okay, and that's why we have taken 1 year. So this is 1. Okay. The minimum of all these 3 is 1. That means I can crush these 2 parallel activities by only 1 week here. Right? And if you look at the cost involved, which is, I think there is a mistake here. If this is 2000, this cannot be 1000. I think this is 10,000. Just 1 minute, guys. This 10,000. Okay. Right? So this 10,000, this 11,000. We have 2,500 for activity B, which is the least. That means I need to crush this activity B first. Okay, and it is as it is the common activity for all. I can go ahead and crush B by 2 weeks directly. Okay, and do the calculation again for the duration and the total cost. Now the total cost is coming to 1,32,800. Now there's only 1 minute left. I want you all to rejoin if the meeting gets over. Okay, once this is done, we still have to crush the parallel activities, and as both are 1 days or 1 week, sorry, we can go ahead and crush CDE first and then CDF later on. Okay, so let us see the calculation for the next step and the crush diagram. This is my new diagram, and the duration is coming as 19 now.